Hi everybody, how are you? Today we're gonna try to talk about the science and the issues they have, but first I would like to discuss the situation, what is going on in science currently in our days. And I will try to keep this as simple as possible and try to use as example, let's say a soccer game where there is 11 players, 3 referees and 2 teams, and there's coaches from one side and the other side. Let's say 10 players playing in a field, those are physicists. There's a goalkeepers, and one goalkeeper that stands in the gates on both sides, either one team or the other team. And referees are mathematics, and the coaches theory. Now we start the game. The game by itself looks kind of chaotic. Everybody's running, making some combinations, try to score. The goalkeeper tries to prevent that score, which is philosopher. And when the one team tries to strike and succeeds, everybody's happy on that team except the other team and the coaches. And if we compare them, the other team also is a physicist and the coaches from the other team is a theory, they're not happy. So actually the theory of the one side of the coaches compared to another side doesn't match. But referees, as a mathematics, they said this everything is okay. And but who is not happy when this got scored? It's a goalkeeper, as a philosopher. So he wasn't be able to prevent that score. And that's okay. It's the game goes kinda by the rules, and everybody accepted that. But let's imagine the different situation. When they're playing the soccer game, and somebody just grabs the ball in his hand and starts running through the field with the ball in the hands. Of course, referee, the mathematics, immediately stops the game and starts all over again. But suddenly everybody starts doing the same from both teams. They start taking the ball in the hands, running one interval with the ball in the hands, then dropping on the floor, leading with the feet. And then referees, as the mathematics, get tied to stopping the game. They said, no, what the heck, it's cool, let him play. And he starts improvise. And let's call it improvisation of the referees axiom, because we call the referees as mathematicians axioms. And the game continues with more chaos, but the referees allows that game because he starts improvising, applying some axioms to the rules, and nobody understands what's going on. And then they start doing another thing, grabbing in the hands, getting close to the gates, putting ball on the ground, kicking into the gates and scoring or not scoring, but somebody trying to kick the ball with the hand, like in a volleyball. And then the referee stops the game again, but suddenly everybody starts doing the same, and the referee says, what the heck, it's cool, let him play, I will improvise. And then he gets, we call it as a mathematician or mathematics, he gets another axiom and he's allowed to play that game, and it gets more chaos and more and more and more. And players are not happy. Mathematicians, okay, they kind of try to stay neutral, allowing and applying new axioms. Coaches are not happy because it doesn't match to the theory. So what we're gonna do? Let's imagine, and everybody get together. The coaches as a theory, the players as a physicist or scientist, the goalkeepers is a philosopher, and the referees is a mathematics. And they came up with another model of game, with another model of rules. Everybody agree on that, and they start playing that game, which will look, let's say, they try to eliminate the chaos from the game, and the new rules of the game is going to be all the players stays across the field in lines. Let's say there's 5 players from one team in one line, then goes another 5 players in one line from another team, and then from the first team continues another line with the players. So there's 5 players in a line, 5 players in a line, 5 players in a line from another team, and 5 players in a line. The goalkeepers gonna be standing in the middle of the gates, only in the middle of the gates. They don't move on the both sides, and the players cannot move in the field. The only thing they can do is just turn around in the same place. And the coaches, as a theory, agree. The mathematics, as the referees, agree. The players, the scientists, agree. The goalkeepers, the philosophers, agree. Everybody's agree. Let's start playing. Referee throws the ball into the field. Whatever he closes, it stops to the player. That team starts play. What they can do, they can just kick the ball to each other without moving in a straight line or in angles to each other. And they decided when to kick to the gates. Turns out everybody then knows the outcome. It's 99.9% they're gonna score. They're gonna score when they score, because the goalkeeper stays in the center, and there's a lot of room around him to make a score. So it makes the percentage like, let's say 99.9%. And that's what happens in this game. But then, okay, let's say boring, maybe, but it's still the game. But it's organized nicely. So what's the point? The point is that the scientists and the theories in a different field of the science, they're trying to find something stable and steady that will make the agreement between all the theories and all the science, physics, chemistry, biology, mathematics. So which one will make a sense? So now, forget now what kind of personality scientist. Let's say there is no more chaos in a game. But okay, you're still the crowd of the fans that watching the game. And still, maybe the game is boring, but when their team scores, they're still excited. The scientists, they stays neutral because they know 99.9% they're gonna score. It just it depends how many times they pass each other in a frame of time. The results gonna be different. But once in a while, that 0.01%, some of the players are gonna hit the goalkeeper, and it's gonna be no score. The ball gonna bounce back, and that's where the players, where the science gonna be excited. So that's the difference between the crowd. Okay, so that's my simple introduction, or how to say, but yeah, the point is, that's how I would describe simply the situation in a science, that right now it's kind of chaos everywhere, and there's such a, let's say, theory or model exists that it will unite all the field of science and make everybody happy. Well, straight ahead I will tell you, I'm not a scientist, I'm a regular guy like you. I went to college but I didn't graduate, so I got I got the basics, only basics from science, and I'm gonna try to do another thing. Yeah, I'm a mechanic. I work all my life as a mechanic, and for the last 25 years, science is like my hobby. I got hobbies like fishing, but science is another hobby. And the last 25 years I've been following and watching all the scientific programs, NASA channels and history channels, discovery channels, and I was thinking hardly, and trying to understand where is the problem, why all the scientific fields cannot be brought together in one unifying theory that will make the game from chaos to order. I came up with the idea, but that requires a little bit imagination, because most of it is requires geometry, to apply geometry, but not a two-dimensional, but three-dimensional spherical geometry, like trigonometry. And I'm gonna try to express my idea the simplest way as possible, and because of that I'm gonna use some regular household items what I got what I got in the kitchen, and some other stuff, because sorry, I don't have a luxury to make an animation or like the cool animation that will show you in three-dimensional, but it doesn't matter, so I'm gonna try, yeah, by using those items what I got now. So most of it is gonna be from what I got in the kitchen, and so that maybe will help you easier to imagine in spherical way what I'm trying to say and what I'm trying to connect together. Let's assume that the structural model of the atom is wrong, and the structural model of the general relativity is wrong. Well, many of you probably gonna say right away, how dare you? That's why I said let's assume, because if the science for so long cannot fall in one place you see the order, that means that somewhere has to be left mistake in the past. And let's come back to the moment when the model of atom was, somebody came up with the idea how the atom's supposed to look, and all the way to the Einstein general relativity, which says that celestial bodies bends the fabric of space, that warps fabric of space, and which we all know that has been a long time been struggled to figure out how the galaxies works, because to applying one theory they're supposed to fly away from each other, to applying another theory is gravity, so the universe is supposed to be shrinking. Then it's been found that it's expanding. So, and that's friction between those theories. That's what still keeps all the science mostly in a chaos. And like I said, let's pretend that the model of the atom is incorrect and the model of the real general relativity is incorrect. Only those two things for now. And I'm gonna try to explain step by step. Okay, not not that. Yeah, and then okay, to make the model work, as I said about the universe that is shrinking or expanding, the scientists came up with a new parameter as a dark energy and dark matter. I'm going to try to figure out how does dark energy looks, and by figuring out that, we're gonna go next step to explain why the model of general relativity could be not correct, and we're gonna make some adjustments for it. It turns out that you can explain actually what is gravity, and I guess that's it. My goal is to try to explain in my way, because that idea it came up, how does energy looks, dark energy looks, and how does gravity works, and actually how it looks. Wish me good luck. But in the end, if you think that it's too crazy, or I'm not enough certified to even discuss this kind of topic, you can turn off your laptop or whatever, your computer, and there's nobody, I'm not forcing you to watch that. But if you're curious, I can guarantee you, because in those 25 years I never heard or see idea like I came up that it would be discussed in the scientific community. Idea itself it's just so simple. It's so simple that I don't know. Maybe somebody had that idea before me, but by watching for all those over 25 years scientific programs, reading the magazines, and I never came up with this kind of idea, which involves mostly spherical imagination of geometry, which one you can apply how to express how looks the energy, and to correct the theory of relativity, which is, let's say, we're talking about the fabric of space and structure of the atom. Okay then, wish me luck, and I'm gonna start from the small. I'm gonna pause it now, recording, and I'm gonna, after small pause, I'm gonna come back and try to start explaining the point of my idea. Hello everyone, I'm back, and let's try to continue. We're gonna start trying to figure out how does that magic stuff the science call dark energy, which you cannot see, you cannot feel. It exists only in the mathematical calculations of astrophysical models of the universe. So where we're gonna start? From what we're gonna start? How to explain that nothing, that zero, that we know it exists, the scientists know it exists, but what we should do, actually, the one thing that I saw watching those scientific programs gave me an idea, which is the Janibekov effect. Probably most of you know what it is. It's also called the paradox of Janibekov, which first been noticed in a space station Mir by the Russian cosmonaut Janibekov. That's what he calls by his name. and he noticed some strange phenomena. When he was unloading some cargo from the cargo module. All the cargo used to be strapped down with like a threaded rods, and those threaded rods got butterfly wing knot on it, and wing or the wing nut doesn't matter. And when they trying to unscrew, you just hit on that one wing, and the nut turns himself out. But when he goes off the rod in the space, he keeps turning, and what he noticed that after several times of turning, he does the flip. He keeps turning again, and does another flip, and keeps turning again, and it repeats and repeats all over again. And I came up with watching that. I was thinking for a long time about that, and I came up with a question: how does energy should flow in a space that will allow that phenomena to happen? And by stretching my imagination, I came up with that idea. Like I said, I don't have the ability to make some animation, but I'm gonna try to just to as close as possible to explain to using just my drawing and some stuff that I have around me. Okay, and let's start to try to stretch our imagination. So simply how it looks at the Johnny-Beckel effect. This kind of is like some part of some metal, and but it's been performed in a space station. So if you turn it in a space, it keeps turning, and then it does the flip, and it flips the sides. And again it keeps turning, and then again flips the sides of that wing, and it keeps turning. Now, and the question is how energy should look, how the flow of energy should look to allow this phenomena to happen. If we imagine this like a metal piece spinning in a space, if you're gonna spin very fast, it will that will start look it's like a circle, like a disc. All right, so that's the spinning motion. Let's say, okay, that's the kinetic energy. That's how it's, like I said, to use our imagination. And here we got that spinning piece. Say it looks like it's a cut-off disc. Okay, so if you look from the front, what you're gonna see is just a line, like I draw it in a picture. And so now, how the energy should flow to allow that happen. And I got this shape. It looks like horseshoe, right? But it's in two-dimensional. No, this is in two-dimensional. In three-dimensional, it will look different. We always are familiar with the baseball ball, right? So now try to imagine the pattern on a baseball ball. and I'll explain you later, a little bit later, why I choose that pattern. So let's say, okay, so we got the disk and the shape of energy, and try to imagine that we gonna bring the scale to smaller to the atom, then even smaller than atom. And this shape, this is gonna be the filament of the energy flow. But actually this picture, you have to imagine that it's smaller even than the atom. And then and that's how it looks, that the energy flows. We'll try to, okay, camera is there. So that's, so who can, I mean, it's not that hard to imagine what I mean by that. That shape, what you see there, like a horseshoe, if you look to a baseball ball from one point, it looks like a horseshoe. And if you imagine in a three-dimensional, so that's how it's gonna look. Why this shape? Because it got a neutral spot. Neutral spot. You have a neutral spot which keeps that spinning motion in that specific position to align with the shape. And like I said, we have to imagine that it's even smaller than quantum scale. Okay, and let's try to put this in a fabric of space, which gonna go to the next picture. So, and then the space we're gonna look like this. It's like look like a horseshoe filament. Well, if we go to the string theory, let's say that is that small string, that string in a micro level, in a nano level, in a quantum level, and even smaller than the quantum level. That's the filament. Which one, if you look in two-dimensional, it looks like a horseshoe. If you look from the other side, it could look different, but I choose just the one side to look as an observer. Looks like a horseshoe. That's gonna make a little bit more easier. And so we got all the space filled up with all that filaments. All the filaments, which is even smaller than the atom. The scale, I don't know, probably I'm not gonna get into mathematics because there's a lot of smart guys, mathematicians, professors that could give who could put the formulas and numbers into that, and to calculate how much smaller that should be than the atom. But definitely it has to be smaller than the atom, and it's so dense, very dense. Okay, let's keep it simple. Very dense. So that's how that, according to string theory, those filaments should look. Alright, but then is another thing. What I found that would be logic to, it's not only talk about the string theories in a micro level or quantum level or even smaller. There should be some macro level. When we're talking about the fabric of space, let's say there should be a string in the macro level that is made of fabric of space, but the string in macro level, it's made from the small filaments, right? Then try to imagine how that macro string structure should look. The idea is the one layer of this macro string starts with the four filaments, like we see, like I draw it here. What is important that those filaments compared to each other lined up, that three of them stands in a vertical position and one that I mark it with pink in a horizontal position. Why it's in a horizontal? Because it's important. We'll find out later why it's important. The position, they should stay in a horizontal position, and let's call it this one filament as a governor, because in mechanic language, in mechanical terms, the government is some. There's the thing that who don't understand mechanics, if to explain simply, it's a regulator. It's a regulator like for the mechanical regulator for the RPM, or it's a pressure regulator. But just call it's a regulator, and then we'll find out later why it's important then that three filaments is aligned vertically, one up, one down, one up, and one horizontally. So, and let's start to make our macro string. If we look from this side, we're gonna see a picture like that, and that's the first layer. If we're gonna look from this side, we're gonna see a picture like this, and then keep turning. We look from this side, we got a picture like that, and keep going, and we're building our macro string. Now, and that directional alignment, like I said, is three on vertical and one horizontal, as they compare to the surface of the earth, right? Vertical and horizontal. And we're building our, from those filaments that, okay, I call that dark energy, the pattern of flow of the dark energy, we're making macro string, and which let's say we're gonna create the fabric of space, right? That's how it should look visually, and you can see those marked with the pink. Those are like we'll call that one position which is horizontal, like we'll call it a governor. They goes kind of like in a spiral. It twists around it. You see, he goes, then he goes in the back, because in this part you cannot see because it's from behind. Then he comes out and he turns around and it goes back, and if we mark it, just make another schematics, just the directions. So we're gonna get the picture kind of like this. Up, one up, the vertical up, horizontal right, vertical down, horizontal left, vertical up, horizontal right, vertical down, vertical up. And this directional alignment is also very important for the further explanation. So let's say we got the, let's assume we got the model of the how this energy looks. Let's say we figure out the flow, the shape of the flow, because which one occurs actually only when the body gets into the spin. If it's in a rest position, like, it doesn't affect. So we notice another thing, that the body comes or activates that relation with the dark energy when it goes to the spin. Okay, in a space it doesn't matter the position. It's a vertical comparing to floor, or it's an angle, or it's in a horizontal. It doesn't matter. It only matters when we are down on the earth, and we know that the vertical spinning position keeps the circle steady in the vertical, and that's why we don't fall from the bicycle when we ride a bicycle or motorcycle. This one filament that makes macros string, it's put it in a horizontal position. It's like a mechanical intuition that you need something that will allow it when you ride a bicycle and you make a turn, you should be able to lean down, because if we got our filaments lined up just a vertical, up and down, then I think it's gonna be, if it's not possible but very hard, to lean on the side. Then you got a spinning motion and moving, spinning motion and moving. Alright, and why in a space it doesn't matter position, if you compare with the floor, and on Earth, it's only the vertical spinning motion and horizontal spinning motion. They works without any resistance, because I remember when I used to still live in Chicago, we used to take our son to Fermilab from those classes, and they showed this experiment with the bicycle wheel and the handle, and you just you spin the wheel and you try to tilt it, and you can feel that force that it pushes back to the vertical position. So that's what happens on Earth when we get back to gravity. So on Earth, but then we have to figure out why that's happened on Earth, and it's no effect with the spinning motion and the space. Okay, so we got let's say we got the model of the energy flow, which is very small, and like I said, it's smaller than the atom, and then we build our macro string that makes a fabric of space, which is this. But is also, this macro string is also actually it's much smaller than the diameter of the atom. How much? It's not up to me, like I said, but I don't think it's going to be a problem to calculate it for the guys who understands the mathematics and together with the physics. It's just what I'm doing. I'm just going with my intuition as a mechanical understanding as a mechanic to trying to using the geometry. And okay, like I said, I draw it. This is we can call it, and we can call it as a key, or the key or the tool to build the macro string. Yeah, because abstractly I draw it. These three loops, it stays vertically compared to the to the ground, and that one is horizontal. So it's like our key to build a macro string. And okay, and our micro string, or the filament that forms the shape of the energy flow. It looks like the shape on a baseball ball. Okay, so we got that. If somebody don't understand, then maybe I'm not good enough to explain that, but I think who can have enough imagination, they can understand what I'm trying to they probably will understand the point where I'm trying to get to. We got the microstring, let's call it filament, and the macro string that we build it from the structure from the 4 filaments spinning in that sphere, but they can also spin in a vertical, 3 in a vertical, 1 in horizontal position, and the macro string gets when we build a macro string, it's kind of gonna look, if you're gonna look in a drill bit, and that empty space that's cut for drilling, let's say that's what fills up the filament that we call the governor, the adjuster. Okay, now, and of course, and when we build our macro string, the directional alignment is also important. So okay, first we got our filament, the shape of energy flow. We build our macro string, and we make a fabric of space. Which of course in a 3-dimensional, we've got one layer, then another layer, then another layer, and that's, we got the dense fabric. We got the dense fabric of space made with filaments, and the filaments makes the macro strings, which forms the fabric of space. But the fabric of space is going to be so dense, like I said, okay, there's another crazy idea. The fabric of space is so dense that the friction disappears. And of course, if we talk about the energy with filament, the distribution of the energy is equal through all the space, through all the universe. Now we're gonna try to get to the general relativity. Okay. We know that celestial bodies, let's say the sun, our sun, we got the fabric of space, and the celestial bodies warps the space around themselves. Okay, it turns out it's a logical idea. The mathematics been applied to it, and it works, and NASA uses and the other countries that go in space, they use it to do the calculations. But for me, okay, let's assume I'm not right, but to ask that question, but okay, it says that the light bends, and you're able to see during the solar eclipse, you're able to see the star that is behind the sun, because the light channels through the fabric of space, and because the fabric of space is warped, it just goes around through the sun, around the sun, and that's why we're able That's why we're able to see it. But on the other hand, if the light channels down through fabric of space and celestial bodies made from matter, warps that space, so maybe it's not right, but just for the second, let's assume that light, if it channels down the fabric, it will pass by us and we're not going to be able to see it. Not going to be able to see it at all if it just goes through the fabric of space and celestial body warps the space. So, and to me it's a problem. But then I start thinking, oh, how we can fix that logically. And how we can fix that logically? Is it a matter is so special that it's able to warp the fabric of space, but on the other hand, scientists claims that the dark energy and the dark matter, it's like at this moment when I am talking, and any moment they passing through us in the millions and the billions of particles. We just don't see it and don't feel it. Okay, it's a question who's passing. We passing as a matter, as a material things through them, or the energy and matter. It doesn't matter. But if the energy and matter is passing through us, which is component of the space fabric, then this picture is wrong. This picture is wrong. So how to correct that problem? And I came up with the idea that the macro strings, okay, celestial, but I agree, it warps the space, but it doesn't pushes the fabric of space entirely out. What happens? It just realigns differently, and how that should look. In a logical way, that the macro strings lines up to the center. Macro strings, they lines up to the center of the any object that is made from matter, starting from the atom. From this, in a single atom, it lines up, fabric lines up in the same, but then it fractizes. Well, that's a good thing. The new one thing that the fractal geometry was invented, and then it fractizes. You got atom, you got apple, you got orange, and yeah, and but the fabric of space, it lines up. We don't know that, but let's assume that that's what it is. So we got just a small cut, and of course those macro strings, one goes and lines up into the center, and the other ones keeps going around. So it's if you will imagine, it's making like a, okay, I'm gonna draw it separately. It's gonna make like a, it's gonna look kind of like this, but also we have to imagine that this is in a micro scale the scale that is even smaller than the atom. Okay, it looks like a parachute. Okay, we took the piece of it just to make it as example. Now, as we talked before about Jennebeck effect, in space it turns, making like a kinetic or angular momentum energy is, I mean, the whole spinning itself is going to look like a disk if you want to spin it real fast, and it's just more easy going to be imagined. So, but what happens when we get close to the Earth's back and we're on a surface of Earth? When the macro strings changes their geometrical configuration. So actually, what we had it in space, we had it as small squares, let's say, if we magnify it, we had a small spheres, that is everything, the energy is distributed equally, and the directional alignment of the filaments is also distributed equally. What happens here, that in a vertical strings, actually I have an example to show you how it's gonna look in an all square and three-dimensional. That is gonna look like, I got this cat toy, so that's how it's gonna look, how those strings goes into the any matter that is in a space, they lines up into the center. The surface, around the surface of the celestial body, of course, it's warped. So the one thing, we got those strings lined up, macro strings lined up into the center, and the other ones, okay, it goes around. So if we're gonna put those two together into one, I put this one, the porcupine, inside of that. That's where we're gonna get the model of the macro strings, how they are lined up around every material body that is in a space. And that's, we cannot see it, we cannot test it, but we can figure out that by applying the phenomena from all those effects, what we can detect and see. Which one is that the spinning motion on the surface of the, okay, the closer to the Earth, where we get the gravity effect. And what happens? Those strings that lines up into the center, they always gonna look vertical compared to compare to surface, let's say, of Earth. And they will keep the, as in a open space, they will keep the spinning motion vertical. But why? But also the other set of another set of the macro strings that goes around in the circles, they create like that umbrella effect, and the distribution of energy stays the same. Again, it doesn't matter, it stays the same. What changes, it's a directional alignment of the energy filaments that makes the strings. So actually what we're gonna get when we got spinning motion on Earth, we got the vertical string making an effect of that spinning motion, and also that umbrella effect that from the circle macro strings, directional effect of the filaments, it keeps that spinning motion exactly in the vertical position compared to the surface of Earth. When we get the horizontal spinning motion, okay, it sits, let's say, on that vertical string, and that umbrella, and that umbrella shaped string of fabric of space also affects our spinning object in equal ways, but actually it's trying to bend it also. If the object compared to the surface of Earth, if we can make like a 2000 kilometer diameter tin plate and start spinning, it's not going to be spinning as a line because of that umbrella effect and directional alignment of the energy filaments. It will bend. Also, it will bend into umbrella. Will bend into umbrella. Now, okay, let's pause it. I'll come back soon. Okay, I'm back again. Took a little break. Let's continue. So far, let's say we figured out the shape of the energy flow, which we call that the filament. We kind of figured out we corrected the model general relativity. But I wanted to tell you one thing, how I came up with that idea, how that funneling effect, how I came up with that idea. This also was I saw on the NASA channel the one experiment that was performed in the International Space Station with the two sticks in the drop of water. I draw it here. And the experiment is a simple experiment about the surface tension. When you get two sticks parallel and they got this O-ring, let's imagine it's a drop of water. When they are parallel, the drop of water just stays steady. But once you put two ends of the sticks together and the other ends you start spreading, the drop of water, because of the surface tension, it starts going towards the junction point. So actually I can recreate that experiment with the O-ring, because if I put some oil on those grow pinners, make them slippery, so it will be the same. If I spread them, you will see that the O-ring starts moving towards the junction point, and that's giving me that funneling idea. For this, to correct this general relativity model. And at the same time, if we will think logically, it turns out that the gravity, of course we still have to, we'll get later to the structure of atom. It's safe to say, I guess, it's my opinion. I'm not trying to force you to believe that, but it's my opinion that it's safe to say that the gravity is nothing else is that the surface tension in atomic level, that let's say that Newtonian apple, the part of the apple that is closer to Earth atoms is less stretch than the atoms on the top of the apple, because the atoms on the top of the apple is stretch, the forces the rest of the atoms underneath it, and it pushes the apple down. So then, by my logic, the gravity is a local effect. It's a local force. It's local to compare if you for the Earth. It's local for the solar system, and it's local for the galaxy. But it also exists where matter appears. In an interstellar, where we got the empty space, we got only fabric of space, which is made from the dark energy and dark matter. Dark matter, we'll leave this for later, because my head is already exploding of that load of all this stuff. What we're gonna do a little bit later, we're gonna get to explain, in my view, how the structural model of atom should look, and I will try to explain why, and how that relation with a different kind of forces with the energy how they look actually, and because in my view, once again, it's only my opinion, because that I think that the energy in material world, it doesn't exist, and it makes more simpler to when we get to calculations and then figure out this stuff, because let's say the energy exists only in the fabric of space, and the rest of it is the forces. It's a different kind of forces which occurs only with the relationships through the energy with the different kind of slipping ratios. I would say again, slipping ratios, not the gear ratios, but the slipping ratios. Slipping ratios, and I would call that VA ratios, and I will mark it that as a V and A. So it looks kind of cool, but it doesn't matter. It's just and that funneling idea came from that experiment from ISS with the about the surface tensions, the drop of water into two sticks, and the idea for the spherical model of the energy flow came from that Johnny-Beckel effect, and when you got those two together, came up with another idea of how the atom should look, and then let's get to that. I'm gonna try to. I'm not saying that, or I'm not telling that you have to believe it or not. You just look at it and try to figure out in your own mind if it's logic or not. Oh, also to make it more spherical imagination of that model of the general relativity. Let's say we take the orange. Let's say it's a sun. Orange is a sun, same color in the sunset. Yeah, we get that. Then we got a fabric of space like a strainer, and when it gets to the and we get that the celestial body bends the fabric. Okay, it bends, but it should also allow that fabric go through it itself. And how it's gonna look in a three-dimensional, like I show you with that the cat toy. but also I would like to show you how we will look our solar system model. We're going to take those drill pinners and start to stick them into the orange. I don't know, I need something, some darker background, but okay, we'll do that. Okay, right here, start putting and putting more. So the sun, but that's not the beams of the light. It's a macro strings going. So okay. Okay, maybe it's enough. I think you got the idea. And if I get that again, the cat toy again. So let's imagine this is our sun. This is a macro strings lining up into it, and the rest of the strings should go in the circles, like making that parachute pattern. And this is the Earth. Let's say it's the Earth. Also with its own pattern of the lining into the center strings, and those strings interlocking with the funneled down macro strings that goes around the sun. And those points in a center, in this point, that's the fact. Maybe it's most strong, and that why? Because in this case it's probably helps more easily to explain the phenomena that I actually don't exactly remember the name of that, but there is a, they call this some kind of like a, okay, it's you call like a window when there's some celestial body like an asteroid or meteorite, small meteorite goes through that area in a space by the Earth. It's got some kind of effect that it could change the direction. It could change the direction. So that's interlocking of those macro strings that lining up to the center. That could be the explanation of that window. Like I said, I don't remember the name, but it's probably could be the logical explanation. And we got all the rest of the planets we got Mercury, Venus, Earth, Mars, asteroid belt, Jupiter and Uranus, Jupiter, Saturn, Uranus, Neptune, and blah blah blah. So it's kind of like that. It should look. I'm still gonna be able to eat that orange. The one also thing, if you remember, was showing you that the key of the directional alignment when we were building the macros string, this alignment, on a break time I tried to make it from the aluminum foil, so it's kind of should look model like this. Those three is a vertical, and one, okay, let's see, one is horizontal, so it's more easy to activate your spherical imagination. So now we're going to try to get to the structure of the atom. Let's say logically, it don't have to be your logic. Let's say from my point of view, from my logic, if everything is filled up with the dark energy, which I got this O-ring, okay, nothing zero, right? Now we try to bend that nothing zero to try to explain something. So we got that shape of the filament. Now we get to the atom. Let's say this model of atom is not correct, and after all those models, logically would be that the model of the atom, the right way, it should be this one. Let's say just a hydrogen atom is the one layer of the electrons. But once again, it's just a view from the front. When we get the view like a horseshoe on a baseball ball, that filament. So it's also view from the front. And if we take that O-ring, we're gonna bend it a little bit less than the shape on a baseball ball. Why? The electron is spinning around the atom. So let's say that the dark energy filaments is holding that in place. But once we apply the mass, because the electron got the mass, once we apply the mass, spinning motions got momentum, velocity, and it tries to open that filament, but not the filament itself, because if there would be no mass, this probably will refractize that shape of the filament of energy, and it would be the same. But once we get the mass, it tries to open the flow, the pattern of flow of energy, and but because the mass is not so big of electrons, so it just opens just a little bit. So which from one side it will look the same. Then we take some other atom with 2 layers of electrons, and is a group 3 with the 3 layers of electrons, and that's how it would look. And if we're gonna make look material fabric, so we got those from the front. If we look from the front, we got this view. Well, let's take the first group, the atoms with the 1 layer of the electrons. So let's say it's gonna look like this: 1, 2, 3. All right. And then another layer, so these are pointing down, another layer is up. But if we're gonna try to see through that layer, in the back we're gonna see that there goes another one, but those 2 already in the back, and the same thing. And those that is pointed up, but in the back is also going to be look like that. So actually, what we're getting circles. If we look through that, that layer, but the layer of the atoms. And so why I choose that pattern? Because to me it's logical, actually, because you get the electron, which got the mass, and it starts try to escape that force of that energy filaments. And what we see all in nature, in material world, that's what makes things round. But okay, but that's it's bit. Let's say, let's put it this way. When it comes to atoms, it's a half circle. The trajectory of the atom, the electron. Yeah, the orbit of the electron is like, if you look from one side, it looks like a half a circle. From the other side, it looks a sign of the infinity. Doesn't matter. It depends from what angle you're gonna look at it. But in the whole layer, if you look at it, it just makes the circle. So if we look in a atomic level, what we're gonna see is the circles. Maybe, yeah, with a microscope, very strong microscope that shoots the light photons with some specific frequency, so you detect the position of the electron. But of course, until today, probably nobody knows how the structure of atom looks, and there's a lot of speculations about that. So trying to bring the new idea how the atom looks, I don't think it looks so stupid. And okay, then we get the atoms. When you look through the one layer, it looks like circles. What we see in nature, all the celestial bodies, the sun, the planets, they also are all round. So in an atomical level, because the electron has mass and it makes that, so that the nature forms celestial bodies also in a round shape, because of those macro strings lining up into the center of the mass, and it builds everything around it because of the surface tension of the in atomic level of the orbit of the electron, interfering with those space strings, space fabric strings, and that's why we see the celestial bodies built in a round shape. But then let's take a solar system. So the solar system as a unit, it gets even more mass. So what we're gonna get as a relationship. So the energy filament shape in two dimension, it looks okay, let's say like a horseshoe. The trajectory of the electron around the nucleus looks like a half a circle. So we get in a model mass, and it's because the velocity starts stretching, but it's not stretching the filament of energy itself. It just fractizes in the slipping ratio, and that's why we got all the material of celestial bodies building into circles. I'm talking about the biology and zoology, and us humans, that we're built in different shapes. We're not round like a orange. In this case, we're not gonna need the legs. We just can roll it. But and then if we take the solar system with 7 of those planets, let's say, then we get even bigger mass. And what we see, the objects start spinning in circles. So we added more mass to the system, and the object starts spinning in circles. So, and the pattern of that force, spinning force, it starts opening even more. It opens into the circle. Now we got that circle. We got the circle. All right. When we take the size of the galaxy, no, just a little bit negative. Turns out that our shape of the circle, it breaks. It breaks, and it starts making that different. I cannot bend it now from this one, but it breaks and it starts making that the spiral pattern. It makes the spiral pattern. It starts fractizes into the spiral pattern. So actually, there's in a galaxy so much mass that it actually breaks, and of course, maybe one of the reasons would be that it breaks because it's a black hole in our Milky Way galaxy in the center. So maybe that's a factor too. But also we're gonna apply that idea also of the fabric of space and the rest of it for the black holes. So what do we got? So the different forces, what we got in the material world, what is occurs in the matter, is nothing else as a product of the relation of the engagement in a slipping ratio with the energy, and we got those patterns that by the increasing the mass in a system, the spinning system, by increasing the mass, the shape, the pattern of the flow of energy is changing because it's interfering with the energy in a slipping ratio. So a little bit mass, it's like a half a circle pattern, bend that O-ring, it's atom. We got more mass, our solar system. We got circles, and we add even more mass and take an example as a galaxy. Our ring breaks and it starts getting shape of the spiral. So, and like I said, to my opinion, it looks logic, and like I said, the gravity is a local effect because of the macro strings is funneling down, and it's a simple logical explanation. It's that experiment with the two sticks with a drop of water that is channels down because of surface tension is different on top and the bottom of the material object, but it's in a let's say it's in an atomic level. Okay, and but then about black holes. Of course, it's a not easy task, but let's try. At least I'm gonna try to give you some idea. It's I don't say it's right, but maybe it's logic. Maybe it's gonna give to somebody different acceleration in the imagination. Let's say we got the fabric of space from macro strings, which is aligned very nicely to each other vertically and horizontally. But what happened in an empty space where you got a black hole? The one idea came from it that the fabric is safe, it gets twisted, not just the filaments, we got that drill bit shape that makes the macro string, but the macro strings itself, the macro strings itself, they get twisted, and you know, and we know because that shape of the drill bit gives additional how to say, additional acceleration for the pull. And is also the black hole should be funneled up, but with that twisted macro strings itself. Because see what's happens, you know, if we try just to push that holding between the fingers the drill bit, if I try to push it, it's hard. But if I just start spinning, it goes in easy. So that's additional acceleration that pulls in our. Why the light even disappears, cannot escape? So as we talked before, if the light channels down through the fabric of space, so when the structure of the fabric of space, it's like made like it looks like a squares, but once you and it channels down through those square shape fabric, but once you start twist all that macro strings, actually you blocking if the light goes in one channel in one spot, and when the macro strings get twisted, actually you're blocking those gaps between the in a fabric of space. You're blocking those gaps, and that additional spin that it creates more pull towards the center, and of course it gets the fabric of spaces gets so twisted closer to the center that it's just I guess it just crashes any matter that's getting, and then it escapes as the gamma ray beam, and well, kind of like that. So as I told you, the idea itself is different. Idea itself is very simple. That if we assume that the fabric of space, according to theory of relativity, is not just to get warped, but the strings actually lines up towards the center of the object, and then another logical explanation that is also there is just nothing else. It's just a surface tension in a atomic level, and the gravity becomes just a local effect, which is not have any difference in interstellar space, and let's say in a black hole, and the whole energy. Okay, there's no energy in the material world. It's just the energy, dark energy that is built from those filament shape and energy flows. But and the black holes is the fabric of space is twisted itself, which I think and to put the mathematics to this idea, what I just told you, I don't think it's gonna have any problems for scientists to do that, and if it turns out that it's working, I'm gonna be more than glad that my video will will help to move a little bit further in the science forward. And I guess that's it. But if it turns out that there's a logical and a mathematical explanation for that, and you can get actually right mathematics for my model, my idea, then I got the part 2, which will actually solve a lot of mysteries, not only in the science but in general. And also by that model, if you start looking at nature, the shapes of the how they behave, the hurricanes, the spinning, the stars in the atmosphere, and then the channels down into Earth, and the tornado and channels down to Earth, and the spinning motion because of the structure of the string itself, and the whirlpool in the water, how it spins, and then it's also channels down. So there's many things that you can look in nature and you see, and you actually see similarities of that simple idea and simple model to how to explain the gravity and how the energy looks actually. Amount, how strong it is, we know. Scientists they calculated almost like the dark energy. It's about 70 plus minus percent of the universe. Dark matter is 25 plus minus, because sometimes they gives you different numbers. But the matter, okay, the amount of matter is it's a 5% that makes in the universe, and the space itself, because of course if you look at the atoms, they say there's a very big distance between the nucleus and the electron, and another idea how the quarks, I mean, an atom and the neutrons, why they actually not spin like an electron, but why they still they keeps the small particles compared to themselves. They don't have any spinning motion. Why they don't fly apart? Because they're not opening the filament of the energy. It fractizes, but it's still the same. It's closed like a horseshoe. And when you put the mass and you give it orbit, the spinning, then you get the velocity, and then the electron orbit starts spreading the shape of the force. Well, like I said, there's no, I mean, yeah, you call it whatever you want it, but all the forces, it's allowed, or it happens, because that the universe, fabric of space, universe is filled up with dark energy, which every force that happens, it just goes through the relation and the slipping ratio with the dark energy. It's a strong effect, less effect. That's why actually when you take the CERN and you look on those pictures, what they see in those experiments when they collide those particles together, actually what they got different patterns, right? They got different patterns, goes from their collision point. One is more straight, one is more curved. But that's actually, that's why everything, it fractizes the trajectory because of this slipping ratio with the filaments of the energy. And yeah, if somebody, if you don't understand that, maybe if somebody can finance, we can make a better movie, and maybe we can find a better host who can bring that idea and the message maybe much better way than I did, and that's why I'm going to leave my the email address and the telephone. But like I said, I don't have a secretary, so if it's going to be too much email, so I'm not sure when I'm gonna be able to answer that. But like I said, if you like that, or if you find it's logic, and somebody maybe okay, some you guys like a scientist, physicist, if you see this, if you find out it's interesting, and just try to put the mathematics, and you find out that it will help you and it will works, then like I said, I got the part 2. The part 2 is it's kinda, it's not about it's gonna be not about the science, but it's also gonna be kinda interesting. Okay, then right now I'm gonna finish my video, and maybe try to ask my friend to edit a little bit, and I'm gonna send it what I think people at least gonna be able to get idea what I'm talking about. Thank you, and have a good day.